Hi, this is MarqueeCrew, and Alteryx 19 in Nashville is just a few days away, and I wanted to go and share a YouTube video prior to the event. Alteryx has posted on Macro Monday, which was yesterday, a post about the CReW spatial match, and I thought this would be a good opportunity for me to introduce people who don't know about CReW to CReW and to explain why I built this macro. Macro Monday is an event that I really didn't think that I would occur in, so I really was surprised when I saw the tweet, and thank Alteryx for taking the time to review my macro. I had an experience with spatial matching that I wanted to be able to improve upon, and as a result, on the Alteryx gallery, gallery.alteryx.com, you can find a CReW spatial match macro. You don't have to have any other CReW macros set up to be able to take advantage of this single macro. And so let's take a look inside of Alteryx and see what we're looking at. I've got a series of polygons, just some near squares, and a series of points. So a point could represent a household, it could represent a occurrence of a cell phone, it could be a person, whatever you want to think of as a point. And what we're doing is we're looking for those points within polygons. Now, I don't have any real data here, so what I did is I used a testing technique to use generate rows. And what generate rows will do is it'll allow me to create 1,000 points from a single point, and will allow me to create 1,000 polygons from a single polygon. So if we're looking at this 1,000 points, we're going to search in 1,000 polygons. So we're actually going to do 1,000,000 searches out of these two tools. And what we're going to do is we're going to configure the spatial match tool to read in the spatial object for the targets as spatial objects, and the spatial field is the spatial object that comes out of these points and polygons. And we're just going to leave all the fields on, and we're going to select when target intersects universe and find those matches. Well, I've already done this for you, so you don't have to wait to see the result. But all records, all 1,000,000 records came out, and they're all matches, which is good. Usually it's the same point and the same polygon. I expect them all to do the exact same thing. And we were able to read the 1,000,000 records, and it took 10 minutes, 42 seconds to run. That takes a little time, so we didn't do that on YouTube. But what I'm going to do is I'm going to run this again, and I'm going to lower that count to 100 and 100, just so that you can see the experience of running. And this should take about 1.5 seconds to run, and 1.7 seconds. So now you can trust me. Now what I'm going to do is I'm going to do this again via the CReW spatial match macro. Now the CReW spatial match macro does use the same image. It's got a little CReW symbol on it, but it's got questions here. So the questions are the macro interface. Instead of using a more sturdy interface, we are using the standard interface tools, and we're going to ask which field is a target spatial object, which one is the universe spatial object, and I also put in here this field called a target ID. So what the concept here is that I don't want to output any fields that I could look up later if I needed them. Because if I was just looking up to see these matches, which records matched, I really wouldn't need the spatial objects, because once I found out that it's a match, it's just knowing, oh, this point matches to this polygon. So ideally, when you're running the CReW spatial match, you're not needing the spatial objects. But if you were, you could always take these target IDs and universe IDs and come back to your data to pick up the fields that you're not looking at. This is a best practice anyway. So if I were highlighting this or writing on the board, the best practice would be when you're taking data into a macro or any process, only bring the elements that are necessary for that into the macro. A corollary would be only output the data that's necessary. So here, I'm just going to come up with yeses and nos. I'm going to come up with matches and unmatches. And here, I'm going to get a slightly limited, only slightly, list of different match configurations. So I wanted the target matches the intersects the universe. By the way, I did allow you, if you want to output spatial objects from the targets, I'll let you output those. Just check this box and you'll see the performance difference in that run. So now we're going to take this, which is 1 million by 1 million. Remember, when we ran this before in 1.7 seconds, it was 10,000 records. This one, which was 1 million outputs, took 10 minutes, 42 seconds to run. And I'm going to run. So we're now running against 1 billion records in this file, and hopefully we can run faster than 10 minutes. And we did. It was 9.1 seconds. So in under 10 seconds, we just ran 1 million matches through. We got 1 million records out, and we got the ID of 0.1 matches to universe ID 1. It'll match 1 to 1,000. I can use a scroll button. I think that'll be faster. And then once you hit 1,000, it'll start back at 1 again. So we've shown the same results. We've been able to validate that the process runs faster. Now, why does it run faster? I'm using Alteryx. I'm not using any tricks inside of this. And I've got the same points and polygons. I've got the configuration set up the same way. But what I'm doing differently is I'm not outputting those spatial objects. So if I were to go here and change this back to being 100 records, I'm not going to change the comment, 100 records and 100 records, and I'm going to output the target spatial objects and hit play or run. It's going to take a little bit longer to run. 2 seconds. I lied. There's a little bit of a benefit, the fact that the data was already run through this macro. So I'm going to undo that spatial object selection and hit run again. And you can see it's now running in 1.1 seconds. So 1.1 seconds versus 2 seconds. I'm going to step back just a second and let you understand that when Alteryx is running, you can't just take the first run of the execution of the same workflow and say that's how long it runs. Run it a couple of times and you'll see you can average those runs out. So we're running in under 2 seconds again, and that's comparison to something that's running in 10 and a half minutes or almost 11 minutes. So what is going inside that speedy match macro? That's the whole macro right there. Not much of a macro going on, but this macro that you see here is actually another macro. So what we're doing is we're batching a macro, And what we're doing is first we're taking in what type of a match are you looking for, and then do you want to output that spatial object as a question, and that goes into this batch macro. So what a batch macro does is it's going to read in my target data, it's going to do something for this control, and it's going to do that as many times as there are control items to run. So it's actually doing is it's picking up that record ID from this target, and it's going to, once per record ID, do something. And here's the universe data coming into this macro. And I'm going to open up this macro. And inside the batch macro, I've done a little bit more documentation as to what's going on here. And you'll see that there are no spatial tools inside of this macro. In fact, this whole tool uses no spatial tools. What it does do is it uses a spatial expression. So inside of this filter here, we're going to see a spatial expression which exists for everyone. If you've never noticed spatial expressions, they exist. And so what it's going to do is it's going to use an expression here, and it's going to say the spatial object is within target spatial object, universe spatial object. And what we're going to do is, based on that drop down that existed in that initial configuration, we're going to see which expression to use, come into the batch macro, and what we're going to do is we've got an action, and this action you don't have to pay terribly close attention to. By the way, I'm going to press Control and the scroll button on the mouse to make this bigger for you to be able to see, in case you didn't know that you could make your expressions more readable, then they can. So I've got a switch, and if I've got this WTIU, and these are just abbreviations that I've created. I'll go back and explain how I got each of them. So I've got an intersects contains a within, a touches. Touches or intersects or bounding rectangle. I'm going to replace this filter with the appropriate formula. So I've got the spatial object intersects as an expression that will then update this expression. And the way that I did that is where target intersects universe. I made that WTIU, where target contains universe. It just shortened the expression for me here, so I updated that. So what we're doing again is we're taking in this one record, this first point, and we're saying to it, are you record ID 1? And that would be the control parameter. So if you're the first record, come in, and I'm going to read in all 1,000 records. And what I'm going to do is I'm going to append to you. I'm actually going to multiply that first record, and I'm going to put on the same record the first universe. And we're going to create 1,000 records out of the first record. And then for that, I'm going to then say to my target, do you exist within that universe, that polygon? If it does, I'm going to output that data. When I'm outputting it, the very first thing I'm going to do is get rid of the spatial object because it's weighty. And if you want to see weighty, we come back to this and show the results of coming through this. This original record is 35 bytes. The original polygon is 164 bytes. But when I looked at a million matches, that turned 40 kilobytes into 205 megabytes. So it really grew. And that growth, that spatial object itself, is slowing down the record. So back to the batch macro. I've now removed the spatial objects, which, by the way, I do have an action that says, hey, I can let you keep the spatial object on if you want. And it will then allow that spatial object to stay in the record. And then I'm going to update my field names from this process and output the data back to you. If you come through the unmatched, I'm going to do similar functions to be able to go and output the data for you, but I'm not going to give you the option of maintaining all of those universe polygons on those records. So essentially what it's going to do is it's going to run all the data through a filter that uses your expression. It's going to then give you your matches and your unmatched. It's going to do that for the first record. It's going to come in for the second record, the third record, the 1,000th record, and run through 1 million transactions for you. The run speedy match, 1.1 seconds for 1 million transactions. I think it's just a little bit clever. The reason why I did it was in advance of a client I was working with who was looking at some very large sets of data, and I knew that the performance of the spatial match was going to slow us down. So I wanted to be able to go and put something out there for everyone that would run spatial matching quickly. If you wouldn't mind, if you do see this post and you are viewing this on YouTube and you've stayed with me, I appreciate you subscribing. Have a great day and hope to see you at Inspire. Bye.